Hello. Let me to present the essential of my work entitled Technical and Economic Study of a Hybrid Photovoltaic System. Recent estimates show that currently 20% of the world's population is still not connected to a main electrical grids. Most of them live in isolated areas. Extending the electricity grid to these locations is not an efficient solution and sometimes technically not feasible. The diesel generator set is often used in isolated areas, but it presents some problems related to the use of fuel and some noise pollution. Both classical solutions cause environmental problems. Right now, we have inexhaustible renewable energy resources, which we are able to exploit easily and cleanly, such as wind power, geothermal power, and solar photovoltaic power. But these systems, their major problem is the intermittent of the renewable source. In this context, the interconnection between the PV generator and the diesel generator in a hybrid photovoltaic system can have a profitable impact on the production of electrical energy, in terms of cost and availability due to the complementary between the sources. In this article we will try to answer the following question. To power a given isolated site in Algeria, are hybrid systems technically and economically profitable in comparison with the conventional diesel alone solution? If yes, what is the performance of these systems? To achieve our objective we used software, and we adopted methodology. The system we are looking to study is made up of the following equipment: a PV field, a diesel generator, a storage by batteries, an electric load. The PV field and the batteries are connected to the DC bus. The diesel generator and the load are connected to the AC bus. The two buses are connected using a bidirectional converter. In this configuration, the load can be powered either by the PV generator, and if there is excess energy it will be transferred to the batteries. Either by the batteries if their state of charge allows, or by the diesel generator, and if there is excess energy it will be used to charge the batteries. In this case the converter operates as a rectifier. The software we used is the Homer software, is simulation and optimization software intended for the study of multi-source electrical energy production installations, PV, wind power, grid, storage, diesel, etc., isolated or connected to the power grid. After filling in all the necessary data, the user gets the most economical configuration with all the details. It also offers the possibility of making a sensitivity analysis against certain input parameters. To achieve conclusive results using the Homer software, we have adopted a methodology. It is organized in several steps. In the first step we will present the installation site, the location of the hybrid system. For this study our choice is focused on the city of Sidi Bel Abs with the following geographical parameters. The second step consists in evaluating the energy resource available on the site. So, you have enter the latitude and the longitude of the desired location, and click on the Get Data via Internet icon, to obtain the solar field of the installation site. We can observe that the sunniest month is the month of July, and the least sunny month is the month of December, with an annual average of 4.94 kilowatt-hour per square meter per day. In the third step we will evaluate the energy demand, the load profile. In order to facilitate the task, we have imported a file which is in the database of the Homer software. This hourly energy distribution is considered identical for every day of the year, and corresponds to the consumption profile generally encountered in isolated sites. So this is a load with an annual average value of 618 kilowatt-hour per day, and an instantaneous peak power of 76.7 kilowatt-hour. It should be noted that the Homer software is only a tool. So if it is started with the wrong data, the results it will produce will not represent reality. Therefore, manual precising work for all important equipment is required in order to obtain a range of possibilities. Research work must be done carefully and rigorously for other input data, especially with regard to equipment costs. The data from the previous steps, the energy resource and the load profile, allows manual pre-sizing of the equipment. The following table summarizes this pre-sizing work. After collecting all the necessary data, step 5 is to enter the data into the software. This is the data relating to the equipment selected in the previous step. The following tables show the technical data of each component. The following tables show the economic data for each component: the initial cost, the replacement cost, the operating cost, and the price of diesel. It should be noted that these values are up to date and were obtained from official sources. To complete, you must enter other data such as annual real interest rate, project lifetime, the time step used in the simulation, operating strategy, energy deficit capacity, and the minimum fraction of renewable energy. Once all the data is entered into the software, we obtain the architecture of the system shown in the figure. Now it is enough to launch the calculation to obtain the results. The results are ranked in order, top to bottom, from most profitable to least profitable according to the NPC, net present cost, the discounted cost over the life of the project, which combines the capital cost annualized by depreciating the component over its life using actual discount rates and the rate for replacement, operation and maintenance. It can be noted that the hybrid system is the least expensive configuration, followed by diesel battery. Then we have PV diesel without storage, and last we find diesel alone. To show the reliability and profitability of the hybrid system, it is interesting to make a detailed comparison between this configuration and the classic diesel alone solution. It is observed that all the parameters of the hybrid system are more advantageous compared to diesel alone, with the exception of the initial cost, which is minimal in the conventional solution. It can be concluded that technically and economically, the hybrid system is more profitable than the conventional diesel alone solution. In conclusion, we can say, the site chooses in particular and Algeria in general has an ideal climate for the installation and production of electrical energy from hybrid system. The comparison showed the technical and economic profitability of hybrid system compared to other conventional solutions.
Thank you for your attention.